Hi, future doctors. Welcome to the next class. In this class, we'll discuss about current density and drift velocity and relation between current and drift velocity. So, what is current density? It is denoted by J. So, we came to know density. We have three types of densities: mass per unit length, mass per unit area, mass per unit volume. So, another one: charge per unit length, charge per unit area, charge per unit volume. So, who is having length? It is having some amount of mass. Why if you are taking mass per unit length? If you have only area like paper or page, this is also having mass per unit area. Volume like cube if you are taking, it is having some amount of mass per unit volume. If it is charge per unit length, these we have names same like that. The amount of current passing through area of cross section. If you are taking a wire, so wire area of cross section is A. So the amount of current passing through this area of cross section, we are calling it as current density. J is equal to I by A. If you are taking small amount of area, otherwise I is equal to from this J bar dot A bar. So for small amount of area, small amount of current is passing. J is equal to dI by dA. Here J bar A bar we wrote because J bar is vector quantity. Current density is vector. Area is also vector. It is having direction. Which direction this area is there? If this area is there in this right side direction of the grid. So current is scalar. I is equal to J bar dot A bar. So from this we will get dI is equal to J bar dot dA bar. If you do integration both sides, you will get current. Sometimes they will give J vector, A vector, they will ask the current. Correct? Next. This is the definition for current density. Next we said drift velocity. Now what is the drift velocity definition? So normally in this conductor, if you didn't connect any voltage or potential difference, so all the electrons and all the positive charges, negative charges will move in particular directions. Okay. But whenever you have supplied battery to this conductor of length L, area of cross section A. So all the positive charges, because here positive end is connected, so all the positive charges will be moving from X to Y. All the negative charges will be moving from Y to X. Okay. So it is having length L, area of cross section A. So this is become positive, this is become negative, X to Y. Once battery is going to be connected. So all the negative charges, electrons, are moving with drift velocity. Why those are moving with drift velocity means whenever you supplied voltage through particular length, we came to the relation between EVL, E is equal to V by L. Some amount of electric field is going to be applied, correct? So whenever electric field is applied, charges are going to move in one particular direction. Already we discussed if electric field is right side, how negative charge will move means opposite to the direction of electric field. What is the acceleration of this electron or charge means if it is starting from rest, A is equal to E by M. Did you remember this? This one we discussed in electric charges and fields. So F equal to QE, F equal to MA. So now A is equal to minus E by M. So this is nothing but acceleration. Next, what is the velocity? So Vd is equal to U plus AT. So 0 plus, so E by M into time, we will take relaxation time tau. Why? Because not only one electron, so many electrons will be there to move. Therefore, so all the time, the average of all the electrons which are moving from one end to another end of this conductor, we are calling it as relaxation time. So finally, this is the drift velocity equation minus E by m into tau they are going to write. So what is the normal velocity and drift velocity? In the absence of electric field, in the presence of electric field, how the charge is going to move. That is one particular direction. X2, why it is moving? Whenever we didn't supply voltage. But whenever we supplied voltage means we have applied electric field. And this X will be starting here, but instead of reaching Y, it is going to reach Y dash. This is nothing but drift, we will say. With what velocity it is drifting, that is drift velocity they are going to say. So we give one equation for this. So this is the equation for drift velocity in terms of electric field and power. Next, mobility they will define. What is the mobility means? Mobility, it is denoted by mu. So the magnitude of drift velocity per supplied electric field. So this drift velocity will be coming whenever we are applying electric field. Applying electric field in the sense applying voltage. So if you apply electric field, then drift velocity is going to be changing. This is nothing but mobility they are going to. Okay. What is VD now you got? E by m into tau by E. So E tau by m. This is the equation and units and dimension formula is important. Velocity, drift velocity units, meter per second. Electric field units, Newton per coulomb. So from this we can write dimensional formula. This is the definition for mobility. Now what is the relation between drift velocity and current? So if you want to get drift velocity and current through length, area of cross section A, if all the electrons are moving with a drift velocity, so I is equal to, we came to know, Q by T, charge by time. Correct? Now here, what is Q means? Total amount of charge in this conductor. How much amount of charge is there means first you have to know how many number of charges are going to be present. So number density, the number of charges per unit volume. So total number of electrons capital N means charge according to properties of charge, quantization of charge, Ne by T they are going to. Now how many number of electrons are going to be present? Capital N is going to be small n into V. So volume can be written as area into length. Now this length is going to be covered by drift velocity Vd. So Vd is equal to L by T they will write. Therefore L is equal to Vdt. Derivation is not required. Just we are writing. So Na Vdt is nothing but total number of charges electrons present within this conductor. So if you substitute in this, so capital N is nothing but Na Vdt small e by T. So T will be cancelled. So I is equal to NEA Vd. So this is nothing but relation between drift velocity and current. I by NEA. What is small n here? Small n is nothing but number density. How many number of electrons per unit volume. So in each bench, three people are sitting. So like that, three benches are there. Total number of people will be 9 people within this volume. Only two benches are there. Only 6 people. Same like that. So depending on its volume, so the number of charges are going to be changed. So this is number density. E is nothing but charge of electron. A is nothing but area of cross section. So this is the current. Already we discussed I by A. So what is I by A? We said I by A is nothing but current density. Therefore, Vd is equal to J by Ne. So already drift velocity equation, another one also we got. Vd is equal to minus E by m into tau. This is in terms of electric field. This is in terms of current. So this is very important relation. Sometimes they will ask only relation, and sometimes they will ask problems on this. Vd is equal to I by Ne. So this is about drift velocity, current density, and mobility, and relation between drift velocity and current. Okay. Now, with this relationship, you know, problems we can do very easily. Okay. So, next class. we will discuss remaining concept of Ohm's law and different forms of Ohm's law. Thank you.